Okay, welcome everybody to I think it's our 7th annual summer book club, which is kind of extraordinary. This summer we are doing a theme that's a bit different from what we've done in the past because we started out as a microbiology journal club that had a summer book club. And now we are pretty much just a summer book club because the journal club part was a little bit challenging to keep going for me. But we've had a different theme every summer, and we've done some themes that are in the realm of microbiology or kind of microbial sciences, genomics, symbiosis, microbiology itself. We did a summer of scientists where we actually read biographies of scientists, stories about scientists. But this summer, because of 2 books in particular that are recent releases that I was really interested in, we're doing the Summer of Physics. So definitely outside my wheelhouse, but very excited about this because there are 2 books, our June and July books were the ones that really prompted me to choose this theme. So kind of before we get into what we're going to talk about today, I will introduce myself. My name is Laura Williams. I am a recently tenured, I'm now an associate professor. Yay, yay. I'm an associate professor of biology at Providence College in Providence, Rhode Island. And actually right below me in my grid is in fact Heather. Heather, do you want to introduce yourself?
Yeah, I'm an adjunct professor at Roger Williams University in Bristol, Rhode Island. And I teach, I'm a biologist. I use that word in quotes. I teach our general education science program. So I have all kinds of sciences, and that's what really drew me to this book club this time around. Well, I've never found your book club before. Now I'm really mad because for years I worked in a microbiology lab and ran a food microbiology lab at Johnson & Wales University, and I want to read more microbiology stuff, but I caught the physics stuff, and I do talk about space with my students, so obviously knowing more about it is always really helpful. And so that's what caught my eye. But yeah, I teach general science, I teach all the different sciences, and physics is my weakest science. So it was a good thing to read some more books.
Definitely, that's an excellent. Last summer we did Summer of Food and Agriculture. Food and agriculture was our theme. So we had
I missed out all the good stuff.
3 wonderful books on that one. But we're very glad to have you here for this one. So thank you for joining us, Heather. Next to Heather in my gallery is actually Joan. Joan, do you want to introduce yourself? Who is not, in fact, iPad. She does have a name besides.
I have a name. I don't know why it does it. Hi, I'm Joan Williams, Laura's mother, and I am a retired person and was not a science teacher, but find this really interesting. So Laura got me into it, and I enjoy hearing everybody talk about it. And boy, there was a lot of information in this book.
We've talked about it a little bit, and so this is going to be a good non-STEM person perspective that you're going to bring, which I think is really, really helpful. So I think that'll be good. And then Nicole, would you like to introduce yourself?
Hey people, I am Nicole Suctio. I tweet as Old Dusty on Twitter, and right now, I guess professionally, I'm a sessional biology instructor. I was at the college in Prince George, British Columbia, College of New Caledonia, and I will be joining the University of Northern British Columbia in the fall to do some sessional teaching. So this video will obviously be time-stamped as the end of June 2021. So currently I am in the Pacific Northwest heat bubble right now, which is breaking a ton of records, and that's my segue into saying this is already a manifestation of radiant energy that I'm struggling to understand, and this book also takes us into further understanding behaviors of radiant energy and particles that I'm not used to, because with biology and biochemistry we have a whole bunch of assumptions about how nuclei, matter, and energy are supposed to interact with each other. That's interestingly, this book tries to get us to kind of think about other ways that can happen that leads to existence for us in the universe as we know it.
Excellent. Many sympathies to you with that's rough. It's really hot there right now. And I know most folks are probably not really equipped for that level of, who is for that level of heat, but even any heat, I think you guys are, that's tough. So hopefully, is it going to break soon? I haven't seen.
Tomorrow our high is 36 degrees Celsius, which doesn't help any of you who are used to Fahrenheit because I don't know the arithmetic well enough to convert it, but like.
That's close to body temp though, right? Like
yeah,
in the high 90s.
Well, outside it does kind of feel like walking into where you grow E. coli, except it's all pavement where I'm at. So it feels terrible.
I mean, it's hot here in
Yeah.
Rhode Island, and it's like 20 degrees colder. than you. Granted, we have a lot of humidity here today, so it's like 98% humidity. So you walk out and it's just like, but I can't imagine. So
I
my
think a lot of people
condolences.
out here, it's transcending their understanding of like what a weather extreme is, because this whole province has been breaking records, as I'm sure it is south of the border on this side of the continent. So
lots of yes, lots of radiant energy that we're maybe not excited about. Well, speaking of that, I should introduce the book. So this is the book that we're going to talk about today. It is called The End of Everything, Astrophysically Speaking, by Katie Mack, who is also a pretty well-known Twitter presence. This came out, this is the paperback version, so I think it came out in 2020, I want to say. But what this book does is it's as you can see, it's not a lengthy volume, so it's really intended to give you an overview of 5 different ways the universe could end. As some light summertime reading. How's the universe going to end? I don't know. Here's 5 different theories. So the chapter list kind of, I won't belabor it, but I think it gives you a good idea of how this book works. So there's an introduction to the cosmos, and then the book has a chapter called Big Bang to Now, where it kind of sets up, all right, here's what we know about the early origins of the universe and how we got to this point. And after we establish that, she goes into the 5 different possibilities about how the universe will end, and they are called the Big Crunch, Heat Death, Big Rip, Vacuum Decay, and Bounce, which all sound not like a lot of fun. And then she has a chapter where she talks a little bit about how physicists make observations and use observational data and conduct experiments to try to address the underlying questions of which of these hypotheses is favored by the data. What are we missing in our data, which I thought was a really interesting approach that she took, kind of what don't we know? What do we think we should have as part of our models, but is missing, that kind of thing. And that's the essence of the book. There's no equations in the book. There's no which, you know, there you can have a debate about whether or not you should try to get folks to be less afraid of math. And I think that's a good discussion to have. But I definitely understand why there are no equations in this book. And I understand why it's all explained in prose and with some figures. But I think what we want to start with is maybe just general impressions from the perspective that you approached it. What were your general impressions of this book?
I loved it. I thought the way that she wrote it, I loved her little pop culture references, and the way it was very clear that she was writing it for people that have no idea what was going on, which I really appreciated because, like I said, biology, not physics, and definitely not astrophysics of all of the physics, right? And I actually said to my husband while I was in the middle of reading it, I was like, this is the first time in my life that I actually understood what string theory was, like what the purpose of string theory was, that it was supposed to explain both the big things and the small things. And I didn't get that. I've never been able to understand that. So obviously, like, she wrote this book in this really accessible manner. And I actually really like that. I really do want to have that conversation about math. I didn't notice it. I didn't not appreciate it, but because I was a math, I like math. So it wasn't that, but I think that's an interesting conversation to have. But I just liked it. I thought it was very well written. It was very accessible. It gave me several existential crises. Even though you know that like the first two, the heat death and the big crunch, can't happen for billions and billions and billions of years, it still sounds absolutely terrifying, and I don't want to be a part of it.
Yes, I think there was towards the end, there was, she has many quotes from different cosmologists and physicists. And one of them says something to the effect of, I've given many talks about this, and people will cry like in the talk as I'm discussing like what's probably going to happen to the universe. Like people will have like a moment and be like, oh my God. She's like, yes, I've prompted many existential crises in people. So I agree with you. I think that was a really interesting, even though the distance from our own personal lives, from when many of these models suggest that the universe will end is so far, it still prompts like a lot of existential thoughts. So Joan, I think I might pester you, because do you mind if I have you mention your background in physics? Because I think this is a good example of like a reader and how they approach it, like what their background is.
No background in physics. The only physics I ever had was physics for elementary education in college, and it was an older man teaching with a lot of young ladies. I think he spent most of his time flirting with us. So I remember nothing from it. So to me, nothing. I listened to the audiobook, and I listened to it twice. And so the first time through, I was like, everything's just coming at me. The second time through, I could understand what she was talking about, but I can't retain it that well because it's still like it's also new. And I'm really happy she put in those pop cultural references, because that's what I can remember the most. I can remember the one about, Dr. Beverly Crusher on Star Trek Next Generation. Well, she's a doctor. She knows she's okay. Well, her next question is, must be something wrong with the universe. And then she goes, yes, and she's right. So yes, that's the part I remember the most. But when I'm actually listening, I can understand it, but I probably have to listen a couple more times to retain it. So I hope that helps.
Yes, yeah, it does help. And you and I talked a little bit about things that could have perhaps helped. We kind of talked a little bit about whether or not having like a little sidebar where there's almost like, okay, if it's been a while since you've thought about what light is and how there's a spectrum, let me just give you this quick sidebar. If you feel like you've got this, just skip ahead to the next thing. I think that could have made things clunky, but I wonder if that would have been helpful to have these little sidebars in there for folks who it might have been a while since they've encountered some of these physics concepts. I don't know if you have any thoughts about that, Joan.
Yes, that probably would have helped, definitely.
And I think that's writing, this is such a complex topic. And I think she did a really good job getting this to be very accessible. And I think it could be extremely challenging to try to write a book that's going to hit everybody who comes to read it and be able to meet them where they are. And I think what you did by listening to it twice is probably a really good strategy, because everything comes at you once, and then you have a little time to digest it, and then you can kind of get it again. And we even, I think, figured out how to slow down the audiobooks. I don't know if anybody listened to the audiobook, but good heavens, it was rapid. Yeah. It was very quick delivery. And so that I think slowing it down helped a little bit too.
Yes.
Nicole, do you want to share some general impressions?
Yeah, so I think Jess and Luke and myself all went with the audiobook option. Jess is amazing at consuming audiobooks. I think she was already through the first 2 chapters by the time I'd started. So for myself, chapter 2 has been listened to about 2.5 times. It's probably going to take another 2.5 times before I feel comfortable with everything in it. But I actually there was a lot of care that went into kind of setting up the origin of the universe and also pulling out sort of the toolbox of observation that gets reused over and over again to describe plausibilities of theories. And again, a couple re-listens. I think every chapter I had to rewind a number of times, honestly. But I think that recursiveness did come through. I am kind of regretting not having a text version just because I think whatever pictures were in there would have helped. So when I went into your DMs last night and I threw down those screenshots, I've been looking for Katie Mack's sort of pseudo TED Talks or presentations. She even has one that clocks in at 37 minutes, and that's not all of her speaking. It's about 20 minutes where she highlights every chapter of the book. And that one's quite lovely for getting sort of the main deal with each of the end of the universe scenarios. The pop culture, I don't know, it resonated with me less because I think I've blocked out a lot of the years that TNG was on because I hated adolescence. But I really, really appreciated how simple some of the mental models she provided were, like with respect to the density of sort of the universe prior to expansion, like at the Big Bang, where all the things were and how those micro quantum level fluctuations basically set distance configurations once things blew apart. Like that was actually really nicely done because that's still very hard to even express in a way that makes sense to us, because these are, again, it reminded me, actually the first 2 chapters of this book, first 3 actually really reminded me a lot of when we went through Life on a Young Planet, which of course is a very biologically oriented book about like when the world was still cooling and was cool enough for the first forms of life to emerge, because the timescales are still hard to wrap your head around. The physical orientations of that world, even though it was an Earth scaled scenario, are still hard to wrap your head around. So with this, I think that she really thought very carefully about how she wanted to put ideas and pictures of ideas in. And also what I also appreciated is a lot of the transparency about context dependency of some of the models. I mean, yes, there's this aim to try and have a theory that draws everything together, but she handled talking about the limitations well and was very honest and unapologetic about it, which I think even for us who do a bit of science, there's a tendency to look at that as a flaw, and it's not. It's just actually being very transparent about assumptions. And I think that's the cool thing about physics, is I think there's a lot more front loading of like, this is how we're setting up what we do, instead of a lot of the biology writing, which is like, there's the big thing that we fit our context into, and it's like, well, this is the piece we looked at, but we don't really at the front talk about where the limits of the study are. We do that a lot at the end. So like, I actually really kind of like that method of bringing, of discussing everything that she wanted to discuss, to kind of have a very clear-eyed and non-polarizing statement of like, this is how the math is kind of making this work. This is where it might stop working. So those are my impressions so far.
I absolutely loved the conversation around like the cosmological constant and how it's literally like, it's there, like we know something is going on, but we cannot for the life of us figure out what it is. And then we go into the conversation of dark matter and dark energy, and we're like, we don't know what these are, we just know that they're there because there's this constant. And I love that she was very upfront about the limitations that physics has, because we just don't either have the tools or the knowledge or the the technology, nothing to be able to find the answers to these questions. And I think you're right. I think sometimes scientists will look at that and be like, well, that's ridiculous. Or other scientists, not necessarily physicists, but, and maybe even non-scientists might look at that and be like, what do you mean they don't know? How can they not know? And I thought that was really refreshing, but it was just so unexpected, I think. Like, I thought we knew more about astrophysics in general.
I think
And we
it took
didn't,
me off
like, right?
guard a bit, because you'd think that to make a straightforward narrative for a non-physics looking public, or a public you assume to be non-physics looking, that you might choose the narrative of this is the way it is, just to give it some linearity and direction. And like,
Right.
it was achievable to make the concepts comprehensible and still talk about stuff we still don't know about yet, which was cool. Yeah.
I thought that was one of my favorite parts of the book, was like, these are the things we want to learn going forward, like that last chapter. And we want to understand what the cosmological constant is, and we want to know what dark energy is and what dark matter is. But we're going to talk about these things still, and we know that they're having an impact on how we study, but also these are the things that we're working towards. And I just thought it was I thought it was so well written in that aspect, that she was very clear about what we do not know as a collective species in terms of astrophysics.
And I think it was helpful for folks with a science background. I think it was helpful when she made a reference to the periodic table, and how when the periodic table was originally getting organized, there were very clear predictions about there should be an element here. There should be an element here. We just haven't found it yet. But the pattern suggests that there's a box right there that something should go. And I think that that's a good thing for non-physics scientists to latch onto as an, oh, okay, all right. So your theories and your math and your so forth, all your data are telling you this is a thing that is a piece of this that should be there, that we should be able to characterize at some point, but we just don't have the tools yet. I thought that was a good, if you have learned about the periodic table in the past, that's a good thing to kind of have as an example, I thought. I see Luke joined us. Hi, Luke, how are you?
I'm good. How are you?
I'm good, thanks. Do you want to do a little, right now we were just talking about general impressions of the book. So do you want to do a little quick introduction? And then if you've got a general impression that you want to share, you can let us know.
Sure. I'm Luke. I live in Prince George, BC. I teach at the local college here, a smattering of biology classes. I enjoyed the book. A lot of it went over my head. I did listen to it as well, and I actually took the opposite tactic that you were suggesting. I listened to it on double speed because I started it yesterday, which was a mistake. So I definitely need to, I saw some of the resources that Nicole and Just shared, and I think I need to dive into those a little bit, because yeah, a lot of it just went over my head. I don't have a strong physics background. Yeah, but I enjoyed it. And there were parts of it that I liked a lot. I remember I re-listened to the bit where she was explaining how large objects small objects that are far away will look larger at a certain point, and large objects that are far away will look smaller. And because I couldn't understand it, and even though I listened to it like 4 times, re-listened to it, I still couldn't understand it. But it was cool that that's a thing.
Yes. If I remember correctly, I think she had a really good figure for that.
Which I was actually curious in the audiobook, because there's at least 3 folks here who did the audiobook. I read it, so I wasn't sure. Was there any indication that there was a figure accompanying parts of the text, or was that not mentioned at all in the audiobook?
I don't remember it being mentioned, but
okay.
I did get the book from the library too, but I didn't get all the way through it. And when I was looking at it, I saw that there were some graphs and figures, and I thought, I don't know if that would have helped or not.
Because I know in an audiobook format, it would be a challenge to figure out how to describe a figure. So I didn't know if they included a placeholder that's like, there would be a figure here, or they just kind
Usually-
of gloss over it.
I missed. They probably mentioned it at the start of the book, because usually when you buy audiobooks, you can look at the figures as like an attachment.
Oh, okay.
Yeah, and so I'm sure I did have access to the figures. I miss it because usually they're like, oh, check out the accompanying PDF to look at the figures.
Okay. That's good to know. I was kind of curious about how they handled that when they had like a nonfiction book that had figures that, especially she actually, I thought it was interesting that in the text of the book, she never actually references like figure 2 in parentheses, figure 4 in parentheses. She kind of just the text copy of the book, the figures just situated at a position in the text where the text around it kind of, it might help illuminate the text around it, but she never says, as you can see from, at least I don't remember, as you can see from the figure, this and this and this and this. And so I thought, oh, I wonder if that's because they can't do the figures in the audiobook, but it makes sense to me that they would include them as an attachment.
So I haven't seen figures listed in the chapter list under the audiobook unless I'm looking in the wrong place, but I also feel like she kind of got around it. Like, for example, with the black body radiation definition, she literally describes the whole range of the spectrum for you for everything. And I think, again, that must have been a lot of care and tweaking to make sure that everything kind of had a narrative behind it.
I thought what I would do, just to kind of wrap up the idea of general impressions, is I'm going to actually read a part of a DM from Jess, who read the book, actually had what sounds like some really fantastic discussions with, I believe, her brother, yes, who has a master's degree in physics. And they had some chats about different things. She couldn't make it today, but she had some good comments. So I thought I would go ahead and read him. So she said, this book is definitely the most entertaining nonfiction book I've read. I thought the author did an amazing job of organizing this book so that it builds on the ideas in the previous sections and chapters and included history, assumptions about the theories, hypotheses, models, and lots of humor. I think this helps to generate interest to learn more about ideas in physics, which I think is true, since the author is describing how physics is integrated in everything from a very small scale to a very large scale. And then she said, I was trying to wrap my brain around expansion from all points in space, but not like an explosion. And my brother, who has a master's degree in physics, suggested an analogy of a raisin muffin, which as you cook it, expands from all points and the raisins get further apart in relation to each other, which I thought was a nice analogy. It's like, yeah, that's true. She had a couple other thoughts that I might come back to if we kind of get to those sections, but she had some great ideas about things that struck her from the book. What I thought we might come back to is, because I mentioned this at the beginning and then Heather picked up on it too, is how this author and how this book deals with math. And I think that's an interesting topic in terms of the challenge that you would have as a writer if you are trying to write a book for the public that is in a field that's very mathematics based. Do you decide to include the equations? Do you not include the equations? She did not, but she did a really good job describing the conceptual ideas about the math that's being done. And then the other thought I had about that was just that I felt like she did a really good job for me, from my perspective, helping me understand where, let me put it this way. In truth, I didn't actually have a really good idea of what cosmologists did with their time, right? I'm like, what do you do as a cosmologist? Like, do you stand at like a whiteboard forever and ever and you just scribble things and people kind of go by your office and go, wow, they look nutty. Like what do you do? And it was in the way she talks about this, she talks about, yes, we do math, but we're guided by observational data. We're guided by existing theories that tell us, here are elements that you have to account for. And sometimes we try to extend that to ask like, okay, if you push this system into these situations or circumstances instead of these, how does that break things? You know, where do the assumptions that you make start to fall down? And I thought it was a really evocative way of learning about how cosmologists approach their work that didn't involve pages and pages of equations that in truth would probably frighten a lot of people. What did you guys think about kind of how math was handled and how math made its way into this book?
I'm going to go first here because, again, if you have studied in the areas of biology or chemistry, you've already got this bias about how things are supposed to work, regardless of whether or not you remember the math. And quite honestly, there's a lot of math that I should know from my studies that I don't remember anymore. But some of those general things like universal gravitation, attraction of nuclei, the fact that everything in biological systems is driven by energy gradients, to show the conventional math and then present a bunch of scenarios where you're going to break the math anyways, to me, it just seems very pragmatic to go at it from qualitative descriptions. Perhaps having a refresher on some of that in chapter 2, which is like, this is what we move towards, as a contrast to this is what we had in like the Planck time and maybe briefly after that, because we didn't have nuclei yet. We had a ton of energy everywhere, like just to understand that whatever that density of energy and heat, well, heat being energy, that density of stuff and energy is just so far outside of the rules that we're using to describe the system of organization of energy and matter that we live within now, which in and of itself is just very overwhelming to think about the possibility that the rest of the universe, well, doesn't have that architecture, right? So I think there might have been like, it could have added to the drama, which is not me making light of it. It could have been an interesting way to actually appeal to people on an effective level.
Yeah, that makes sense to me. Heather, did you have thoughts on that too?
Yeah, I was gonna say if my students serve as a general spread for the general population, if they opened a book and saw any math equations, they would immediately shut it. So and I'm one of the few science instructors that also I'm like, if we don't have to do math, I'm not going to push it because it's just going to add that anxiety and it's just going to push you away from it. And so I think her approach was very pragmatic because to me, it just, the way that Nicole just explained it, like if you're going to show the math and then break it, did you need to show the math in the first place? Or can you explain it in a way that we're breaking the math? You didn't necessarily need to understand the math because we're thinking so far outside of the math that we know, that I feel like even if you got them to understand the original math, at least a general public, you know, they might not understand why you need to break the math. I like I said, I didn't even notice that there were no equations, and I don't know why I didn't notice it. I think I just enjoyed reading about physics without seeing the equations, because I have a halfway decent math background. I would sit there and try to figure out the equations and what all the variables mean. It would take me like 3 times longer to read this book if it had the full equations. And then I'd have to go back and figure out where all of those things, whereas her qualitative explanations of the math, they were amazing. Like I've never read anybody who can explain math, and complex math at that, in a way like she did in this book. I think it was really smart for her to keep the math out if her goal was like a general population like a non-STEM reader population, if she wanted other people to read this book. I think adding math could have been interesting, like Nicole said, for those of us that do have, you know, the background. But I think she wanted as many people as possible to read this book. And I think it was really smart for her to do it. And she did it very well.
Yeah, I think there was, in particular, I think it's the value of the cosmological constant, like the W equals -1. And there was a discussion where it was, if that value is just ever so slightly under -1, that dramatically changes what's going to happen. And there was a section in the book where she talks about the fact that lots of people were operating under the assumption that it can't be less than -1. And so they'd said, and she gives a good analogy where she says, it'd be like trying to measure, people thought of it as, well, it's trying to like measure height. Like no one can be less than 0 inches. Like you can't be negative height. So obviously this is the floor for this value. And then some folks came along and said, yeah, but is it the floor? And then they pushed it just a little bit outside of that. And that really kind of did a lot to kind of break the assumptions and the outcomes of what they were seeing and what got predicted. Which I think is, you could have belabored that with pages and pages of equations about how you would derive that value and so forth, but she got it into like, if it's less than what we assumed, very different things will happen to the universe. Thank you. And you're like, okay.
I also liked that she said that at multiple points. She was like, I could spend an entire book talking about how we derive this equation, but I'm not going to, because it's going to bore you. Like, let's get to the good stuff about how the universe is going to rip apart now. And I thought again, like, I thought that was really wise of her to acknowledge that not everybody's going to find the nuts and bolts of this interesting. I doubt I would, but I think she knew exactly what information she needed to present in a way that was accessible, while also kind of like that self-deprecating joke, right? Like, yeah, I'll do this in my free time. I think it's cool, but you're not going to think it's cool. And I think that helped, right? Like, I think it made it, I think it just made it more real.
Well, because I think you do have, I think to some degree, you sometimes have an issue where people will gatekeep, that they'll say, like, if you're not willing to figure out how to do the math, if you're not willing to take the time to understand the equation, then I'm not going to waste my time explaining to you why the equation is important and what you learn from it. That does sometimes happen. And I think that's really unfortunate, because, you know, people might be more interested in learning the details if they know what the punchline is. You know, if you say the punchline to you understanding this equation is whether or not we get this terrible fate or this slightly less terrible fate, but we'd prefer that, wouldn't you perhaps want to know how this works? You know, I think that's it's better to not gatekeep that, and to kind of help people get to where you want them to go, which is, what's the outcome of this, and what are we learning about physics in general and the physics of our universe.
And oh, go ahead.
I thought the part was interesting too, when she was talking about gravity, and she was talking about how we, you know, we walk around and everything, but you pick up a cup and the cup does not resist at all. And that, can't remember what that was related to, but that was really fascinating, that yes, everything stays down, but if we want to move it, we move right through the gravity. Yeah. And like the other thing she said too about, I believe she said, Einstein's theory of relativity, they have not been able to break that. They keep trying to break it, which is kind of amazing for the period of time when he developed that.
Yeah, I agree with you. I thought that was neat too. I remember the part about gravity where she's kind of trying to illustrate that it's a somewhat shockingly weak force. Like, yes, it is really important, but like, I have just defied gravity. Wow. You know, that's, and you kind of, when you stop and think about it, you're like, oh yeah, that's true. Like, that's interesting that we could do that. And those are good aha moments that I think are better described in prose, I think.
And I think also knowing Katie Mack's background and her, like, her Twitter presence, I mean, that ties back to that gatekeeping. Like, Katie Mack is all about making science accessible to anybody. And and she's done it so well in an informal capacity, using, you know, like in her talks, but also like using Twitter as I mean, you get 280 characters, 200 and whatever, 80 characters, yeah, 280 characters. And I mean, she obviously uses like threads and stuff like that, but usually by the end of her thread, I'm like, oh, I didn't actually know that. And she's very quick to call out people for doing exactly that, for gatekeeping. Like, there's no reason that we need to bore people with the details, because they can't understand the bigger concepts. And that's the kind of like this whole philosophy of the way that I teach. But it's like, it's kind of this idea, like you don't need the minutia. That's like the content knowledge. You need to be able to be fluent in the content, and that might not mean you know every little single detail, but you can talk about the 5 different ways that the universe is going to end and what that means for the universe. And I think that's far more engaging, obviously, and then it can lead to people being more excited about it.
One of the things I wondered as a reader, and we've read many books of science written for the public, and so one of the things I've always wondered as a reader about the author is, like, here's one of the things that I can guarantee you about me having read this book just once, is I will at some point probably be attempting to describe the big rip or heat death to like my husband, and I will accidentally explain vacuum decay. And like, I am not going to keep these straight. It's going to be like, there's a thing and it's like dark and it might be energy, it might be matter. I think there's both. And then this will happen, and then there'll be a bubble and it will expand, and then your feet will disappear, but that's okay because it'll happen really quick and you won't notice. And I'll probably mash about 4 of these together at once. And I've kind of wondered if as an author, you just decide, I'm okay with that. Like, I'm okay that people are going to finish this book and they're going to do the big crunch, rip, decay, death. And that's the model that they're going to tell their friends that they read about how the universe is going to end. I assume that that's something as an author, you kind of have to go, all right, I put this out into the world and I've kind of done my best, but people are probably going to end up kind of mashing some of this together and not keeping things straight. I almost thought to myself, if I had more time, I would have actually drawn out like a table for myself that's like big crunch, here's like the defining elements of big crunch, like big rip, here's the defining element of big rip. Because
oh, sorry.
No, it's just some of the concepts did mesh together a little bit, but it seemed like each one had like a characteristic element that kind of defined it, I thought.
This literally just happened to me in class, because one of my students asked, like, I've never been asked this question before, so I wouldn't have been even being able to come close to an answer, but it was, how do we measure the distance of far off galaxies? And I was like, I don't actually know. But now I do. And I was like, we use supernova, and yeah, we use supernovas. And I couldn't remember anything she wrote about how they use like the light to the backscattering of light. See, I don't even know. And I think that's a really good question, is like, obviously I know more than I did before I read this book, but I probably don't know it well enough to explain it to another person. But I think that's an interesting question to pose to an author. I'd love to ask.
Yeah. So are you okay with the fact that, you know, I am definitely going to smash some things together and be like, that's a thing. That's what's going to happen. But I think the outcome of it is that, I mean, I will hang on to this book. It will go onto my shelf. And so should I find myself in a conversation going, yeah, the false vacuum, but then there's a true vacuum. Something has to bump you over the divot. Hang on a second. And then you go off and you kind of find the section. And I think that's valuable to have it as a resource where, you know, I don't know if anybody's ever tried to Wikipedia some intense physics stuff, but you can find yourself.
I tried doing that last night, actually.
You can find yourself in gatekeeping land again, where it's like, well, let's run through the math on this. And you're like, can you just tell me where the divot is? Which one has the divot? Like, is that the vacuum decay? That's what I'm looking for. And so I think that this is going to be useful on that front for sure.
I think you bring up a good point though, with respect to the fact that like, we've been in sort of an era of like digital information being accessible to us for like a while now. And so like, I feel like this book has been released into the world where they know people are going to be Googling things, right? So that is helpful.
I wonder too, like if you study a field like cosmology, which the general public, which I include myself part of, isn't very familiar with, if it's kind of a little bit of the, like you don't want to focus too much on people understanding the concepts perfectly. You just want them to have an understanding at all of that field. Like it's kind of the thing, like good is or great is the enemy of good. You know what I mean? Like maybe for the author, she just wants, like, if you are now familiar with the term heat death or heat decay, I've done my job, because prior to that, it wasn't even something that was on your radar. You might not know exactly how it works, and you might get it kind of mixed up with some other concepts, but it's something that you are aware of now. And so I've done my job. I wonder if maybe that's a way that she thinks about it. I don't know.
Yeah,
I will say,
I could see that being a really valuable outcome of this, in part because certainly towards the last chapter or two, she talks a lot about where are we going next. And I felt like to me there was a subtext of, hey, if you're somebody reading this and you've wondered why we should spend so much money on a particle collider, well, guess what? Here's why. And I think that would be on its own just a valuable outcome, is getting people to understand, okay, yeah, that's why we need to put money into these telescope projects. It's not just because people are pointing at the same stars they've always seen. There's actual experiments that they're doing, which I don't know that everybody, I mean, certainly, I said this earlier, I didn't really have a good concept of what a cosmologist spends their time doing. And the fact that it's discussed in here as we make observations, we make predictions, and then we need to do experiments. I'm like, oh, well, yeah, no, that makes sense. Of course you'd want to do that. You need tools for that. You need telescopes for that, sure.
Yeah, that would be huge for her and her field, just doing exactly like you said.
there's also such a misconception about particle colliders and that kind of thing as well. I mean, when the Higgs boson when they were right in that like moment where they were trying to find the Higgs boson, there was this idea that we would, rip a hole in the universe, right? Like, it's the universe, people. And I think that's like the point that she was getting at. Like, yeah, we can make particles go really fast on Earth, but it's on Earth. Like, we can't do that. Like, what we're doing on Earth is so tiny in comparison to what is happening in the universe. And I think that's part, I think that's part of her point. Like, trying to dry up some of these misconceptions that particle colliding is going to cause an irreparable rip in the universe, and we're going to end up in another universe, and this is the God particle, and like really trying to make sense of what cosmology, the study of cosmology, actually is. And I think, like Luke said, I mean, as long as maybe people have a better idea of some of these words like heat death and vacuum decay and the big bounce, it's a little bit better for her and for other cosmologists when they go and try to make another particle collider somewhere on planet Earth. I don't know where you would put a larger particle collider, because when she just, I always fall over when I hear that, like, the CERN particle collider is like 26 miles of underground tunnels. I'm like, who built that?
And
Um,
I think what they said is that they want to build it because this really stuck in my brain, because I agree with you. I always think, wow, that's a huge underground track that you've just built. And I think the one they're proposing, they want to build it adjacent, because the whole idea is that they'll use the Large Hadron Collider as like a spin-up track, and then they'll
And then
shoot them off
shoot it
into the
out
other
to the
one.
new
And then
one.
and I'm like, oh my gosh, wow.
Yeah.
You got to get these things going very fast.
And it's still not going to rip a hole in the universe like that. Like we do not have that capability. And I think that's kind of what she was going for as like a whole idea, you know.
Yeah.
I will say though that the one I won't get mixed up with is heat death, because I thought heat death was burning up, not that heat would die. And I was blowing up my mind. It was like one of those moments. It's like, oh, entropy. Oh, this makes so much more sense. So we're all just going to freeze to death. Great.
The death of heat, which right now to Nicole might sound very appealing.
It's
So,
a little appealing.
just a little appealing. So, I try to keep us to an hour because I know everybody's time is very precious. So I thought maybe one of the things we could do to close, we didn't really kind of dig into the book chapter by chapter, but I don't think we really needed to, because all of it kind of served the broader conversation about understanding how the current state of cosmology and thinking about how the universe will end. But I thought what I might do is ask, kind of as a closing thought, and I'll pester everybody about this, even poor Luke, who was listening to it at 2 times speed. What's kind of the one thing that, and we've talked a little bit, some people have mentioned a few things, what's kind of the one thing that reached out and kind of like whacked you in the face from this book that you maybe didn't know about before? I could go first. I was really, the black holes evaporating was new to me. I'd never heard about that before. And the idea that you could have those quantum fluctuating paired particles, and one of them would get sucked into the black hole and one of them would go, oh, I'm sad, and just pop off and become real. It's like, wow, okay, that's new. I didn't know anything about that. That was something I knew. Just black holes evaporating in general, I had no idea. And then the idea of these like paired particles kind of popping into existence, and then the two of them they should just pop right back out of existence, but then they happen to be right on the edge of the event horizon of a black hole, and there's the fate of them. I thought, okay, that's not a thing I knew about. That sounds very interesting. Anyone else want to share their, here's the wacky thing?
I thought it was interesting that there's black matter and there's black energy, and that there's something there, but they don't know and they can't see it. So they call it black matter and black energy, which I guess it means I can't see it. So that was like, okay. And they're two different things.
Yeah, I think I don't know that I had actually understood why they called like dark matter. I mean, I think I knew it was because I thought it was because it was kind of mysterious, like it's in the dark, they can't really figure it out. I didn't realize that it was because their theory predicts it, but they just cannot detect it at all. Like all the math and all the theory says it's there, but nothing, that was my impression, is like nothing none of the tools we currently have are actually able to detect it. It just evades detection entirely, which I think is probably very frustrating if you're a cosmologist. Any other? Yeah, Heather.
Mine I mentioned at the beginning is like, this is the first book that ever really solidified that there are different physics that work for small things and there are different physics that work for big things. And that, and I mean, I knew that, but I didn't understand the need to combine them. Like I didn't understand why we needed this grand unifying theory. And I actually think she makes a really good point that maybe we don't need a grand unifying theory. And that's an assumption that we're making, that the physics is going to be the same, but maybe it's not supposed to be the same. But it was the first book that I sat there and I was like, she explained what string theory was, and I was like, I get it. Like, it didn't make sense. I've read Wikipedia articles. Because students have always asked what string theory is. I'm like, I actually have no idea. Like, I literally have no idea. I can read the Wikipedia article and I'm still not going to know what we're talking about, because I've tried before. But this just made it super clear that we do need to understand the physics in both. And if we can kind of figure out if there is a connection between the physics of the small and the physics of the big, it might help us understand the universe a little bit better.
Yeah, I like that too. I think that was to me, I think you could have probably lost yourself. Another author would have probably lost themselves in all the interstitial space between the idea of there's small scale physics, there's large scale physics. And they would have been like, yeah, but in the middle, there's all this stuff and it goes together. She was like, no, there's small scale physics, there's large scale physics.
Like, I've
They
tried to
don't
read
always
Hawking,
gel the way they should.
right? Like, I've tried to read Hawking and
Yeah.
it's so much. It's just
Yeah.
too much. And he's trying to do the same thing. Like, and I just can't get past kind of the pretentiousness that Hawking writes with. Like, you need to understand this to understand anything.
Right.
Whereas she's like, you don't need to understand this, but here, have fun with it, you know? But yeah, I think she did such a good job of being like, this is what we think, but maybe it's not actually the case. And that's an assumption that we're making, that we need to find that.
Yeah. Luke or Nicole?
I think for me, the biggest thing that I got from this book was just how dynamic our universe is. So like, I was always like aware that, well, and this might not be the case, but that the universe started as like a singularity, or it's suspected that it started as some very small condensed high pressure thing, and then the Big Bang happened and it's continually expanding. But then her discussing how it may start like coming back together and then bounce back again, and I was like, oh, that's really weird. I never thought of that. So that aspect I found pretty wild. And also just when she was talking about how, like, because the universe can or may come back together and bounce back, and so this current organization of particles that we see right now could happen again, and looking at probability will happen again. So there'll be like that whole multiverse thing. There'll be like a million different versions of us having this conversation at some point, you know, which is kind of like a mind explosion.
Yeah, definitely. The fluctuation stuff where she kind of talked about like how probability works across, and I'm going to get this so wrong, but like kind of how probability works. And there was a section in particular, I think, where they were talking about entropy, where she said that there's a couple of physicists who worked out some kind of math with a set of assumptions where they said, you know, if you watch it long enough, a box of piano parts will assemble itself into a piano. It's like, okay, all right. But that I agree. I think that was a really interesting part of it too.
So I have to agree with Luke. I actually just love the idea that we need to keep taking pictures of galaxies, because we're both looking at the past and then understanding the dynamics of these distance relationships at the same time. Like, that is such a cool idea that we get all that from observational data, you know, not necessarily a hypothesis. I mean, there is a hypothesis underlying it, but it's just like, we need to take more pictures. And I mean, if you've seen any of those Hubble field, Katie Mack actually has a couple talks where she starts with just one of those field images that are colored in, and there's about 10,000 galaxies in them, you know, and they're all at different distances, which means that you're looking at all different ages of some kind of stuff and some kind of energy. There's images of galaxies interacting with other galaxies. So we've got all these other pieces that are telling us about how stuff might go down in the Big Crunch. And then the clapping brain thing. So I didn't know brain was spelled A-N-E in the audiobook, and I was just like, wait, are we talking about just perceptions that are, I mean, yeah, no, I literally thought about like literal brains smushing into each other every so many centuries, which is not what it was, but at the same time, it's just kind of an interesting concept of the cyclic universe, that you've got this other thing where the rules are all different and it's occasionally gonna smush into whatever the prevailing universe is, cause some problems, and then make some other stuff, and then we wait for that to happen all over again.
And I lost her a little bit when she was talking about the bounce and the idea that you had, I mean, the idea of extra dimensions. I mean, I've watched The Twilight Zone. I know how that works. The idea of extra dimensions, I was like, okay. And the idea that they could even be just very tiny, I was like, okay. And then she said, and then there could be other 3D universes within those extra dimensions, and they could be trying to talk to us with gravitational waves. And I went, you've lost me now. Like, how would that even work? But the notion that that's something that's potentially supported by some of the data. I mean, it sounded to me like it's by no means a settled question that this is what's happening. But, and I think in the end, she said kind of the more recent data they're getting kind of suggests that maybe this isn't happening. But the only reason anybody cooked up this idea in the first place is because the data were kind of telling them, well, maybe this is what explains this.
Do you recall if some of that is grounded in the fact of how much of a proportion of the universe we expect to be made from dark matter and dark energy? Because like that, this is me maybe overreaching, but that seems to make a lot of sense because it's almost uncharacterizable at this point. But like,
and it has the same density, no matter, like the universe is expanding, and it has, which like, it took me so long to understand concentration. For whatever reason, it just broke my brain, like way back when I was, you know, a young person. Like the idea that, well, it's the same concentration if it's this or if it's a ginormous thing, it's the same concentration. I don't know why, but that took me a long time to gather. And so this idea where she said the universe is expanding, but the density of dark matter is the same no matter what. It's like, but that's not how concentration works. So that's, I think, I can't remember, because I know that's also the part where she's talking about the various quirks of gravity that they still haven't adequately explained, like why gravity doesn't want to slot itself into with the other forces. But yeah, I don't know. All right, well, we've gone a little bit over 2 p.m. So thanks everybody for, Luke, thanks for joining us, even though you're trying to cram through through the book. Hopefully you get a chance to read it at a more leisurely, or listen to it as a more leisurely pace. But yeah, thanks to everybody for joining us. I think it's always fun to discuss these. Heather mentioned, this was her first time joining us, and Heather mentioned when she first came on that she finds it a lot more motivating to read nonfiction books when there's a group that's going to discuss it, and I totally agree. So I'm always grateful to everybody for making the time to get the book and read the book and then come to this. So thanks everybody for that. Our next book for the summer is The Disordered Cosmos, and I'm very excited about reading that. That is the second book of the two that really prompted me to pick this theme. We don't have a date yet, but I was looking at the last Tuesday of July to kind of mirror this last Tuesday of June. I'm happy to move it if people want to attend and that doesn't work for them. So please feel free to email me or tweet me with your availability if you want to make it, and the last Tuesday of July at 1 p.m. Eastern time does not work for you. I will happily work around people's schedule because it's always nice to have a good group. But that's our next book. I will make one plug to, if you haven't yet voted in the poll for the third book, I'm going to leave, the poll is still open. I'm going to leave it open for the rest of the week, and I'll try to kind of plug it a little bit more on Twitter. And then I'll go ahead and announce the third book so that people have a chance to start trying to secure that from libraries or audiobook things or so forth. But if you want to have a look at the list, it's on the webpage, and there's a poll at the bottom for the third, to choose the third book, which will be our August discussion. So with that, thanks everybody. It's really great to see everyone, and I hope everybody is having a good summer and trying to stay cool as much as possible. So thanks, folks.